Good evening, everyone. And it is 4 p.m. in Dubai time. And we are going to start the Insights Lab webinar series, episode 2, which we call the Insights R. Thank you, everyone, for all the registrations and joining in this wonderful session by Ahmed Rafat, who has been our star guest speaker, I would say. He did a session last year in September, and what a response we had got. It was amazing. So we definitely thought with the current situation where everything is going virtual, he could reach out to a wider audience. And this is why we wanted to do this session. And the topic itself is very interesting, which is about fraud detection using AWS. So once again, for all of you who are joining from different parts of the world, and welcome to the Middlesex Insights Lab webinar series. I'll quickly give an introduction, and then I'll hand over and introduce Ahmed Rafat. Just to talk a bit about the Insights Lab, it is part of the Center for Innovation and Human Experience at Middlesex University. We try to connect the industry partners with the data analytics community in order to have a stronger exchange of meaningful insights, which is what the name of the Insights Lab stand for. We do organize a lot of hackathons and public events and webinars, which could be useful for the community. My name is Krishna Das, and I'm the founder of Insights Lab and also associate professor of data science at Middlesex University in Dubai. So on behalf of Insights Lab, CIHX, and Middlesex University, we welcome you all to this webinar. This is the fantastic student team that has always been working for the Insights Lab, and thank you for coordinating all the efforts to make this and other events happen. Today, we are going to talk about something really interesting, which is the fraud detection. And before handing over to Ahmed, I thought I could just pin down 4 main problems or interesting reasons why fraud detection is so much appealing in the area of data analytics space and community. And this particularly takes me back to my previous role in Majid Al Futtaim, where we used to talk a lot about the Najm credit card and figuring out the fraud detection patterns. So in my experience dealing with the fraud detection problems in analytics, there are 4 different problems that come to my mind. And of course, I'll leave it to Ahmed to tell if he agrees to that or not. First and most prominent problem I see is that the fraud patterns are changing over time. So this is not something that stops at a particular point of time and you have the solution and you say, okay, this is a generic solution that can be used in various models. The thing is, these patterns are constantly evolving and changing over time. One of the main reasons why fraud detection is very appealing to me is because of the class imbalance. And now what happens is, let's say you have a data set of 10,000 records and you will have 6 to 10 or maybe 100 fraud cases. Remaining all the other cases are non-fraud. And when a data scientist reports something like, hey, we have got 99% accuracy for this model, it really doesn't make sense because that 1% is what we are actually hunting for in a fraud detection problem. So again, that is one of the prominent reasons why it is always a classic analytical problem domain in the world of data science. Thirdly, the interpretations of the model. Hey, we are going good. There are a lot of predictions and there are a lot of models that are doing the prediction. But the real question is, why is this happening? So more on the interpretation of model rather than hunting for accuracy. So the interpretation part is always something that is really challenging when it comes to fraud detection. And finally, of course, the feature generation process could be time consuming compared to other cases. So these are actually 4 key problems that I think makes fraud detection such an interesting one. And who else better than the man himself, Ahmed Rafat, who could talk about this beautiful problem that we face in the world of analytics today. Ahmed is a senior solutions architect at Amazon Web Services, and he has got fantastic experience across analytics, machine learning, and AI space, more than 15 years of experience in IT and security. He has contributed a lot in the AI and ML community, big data analytics, IoT, microservices, and so on. He has worked with several government entities. He has been always kind and believes in the fact that it's better to reach out to community to upskill people in the world of AI and machine learning. So without delaying it further, I would like to introduce Ahmed. And just a word before I introduce him, you could have your comments or questions coming in. So please use our comments space in order to keep the questions coming in the comment space. And, as and when we see fit, we'll take up your comments during the presentation. So it's indeed my privilege and honor. We welcome Ahmed. Adding you, Ahmed, to the stream.
Yeah, thanks, Dr. Krishna, for hosting. Pleasure and honor last time to be part of your face-to-face session, and as well being honored here to have this session remotely. Looking forward for the next session to be live on the university soon when we remove the lockdown. So again, good afternoon, everyone. Good morning, depends on your time zones and where you are. And thanks for joining us. My name is Ahmed Rafat. I'm a senior solution architect in AWS. And today we're going to be talking about the fraud detection, which is really an interesting topic. And it's getting more and more interesting now because of the situation. A lot of things is going online now. So I hope you enjoy the session. So the session will be a couple of intro about the fraud detection, how we deal with it in Amazon.com and how we deal with it in AWS as well. What's the tool is available for us. We're going to be part of demos as well. So if you are a data scientist and you're interested to see some Python code, that's going to be showing this here. As well, if you are a big fan of math, and a couple of equations are going to be touching based on some of the equations today. But don't worry, that's not going to be much dive deep on the equation compared but what we are trying to play here. Okay, perfect. So Dr. Krishna mentioned about the importance of having a fraud detection. And if you look to globally now, for example, in 2016, in US only, there is a 9 billion loss because of fraud. And globally in 2016, and that's like 4 years back, it was 22 billion. And actually, it was predicting to be next year as 32 billion. And if you ask me, I can even predict is because of the current situation and because of the rush that everyone is moving online now, I can see that this number, unfortunately, can go higher and higher. So let me share with you from our experience as an Amazon.com or mainly as an AWS, which I'm presenting, is how we see this is actually a big problem. So definitely we are the biggest cloud provider globally, but we are providing our service as well as subscription online services, as you know, right? It's a web service. So we as well, we, like any organization online, we're facing a lot of fraud, right? There is a lot of people try to do fraud actions on us and on our websites and trying to utilizing these services in a not appropriate way. Let me share with you a couple of this experience and a couple of those examples, just for you to know the nature for us as an AWS. We are an web services provider. We provide more than 200 services over the public internet for utilizing IT as a service, and you pay on demand after you utilize the service, which is actually making for us more harder to think about the situations when it comes to fraud. So think about multiple scenarios. So the first one, things related to the payment fraud. So someone can get a compromised or a stolen credit card and try to use it in AWS. So we have a lot of techniques that we be able to stopping that. And this is why we come here today to share with you the solution and the services that we build and we offer as well as a service for you, you can utilize this. But that's a couple of them. Like, as I'm telling you here, like someone gets stolen card and say, I'm going to be used it on AWS. We need to stop that, right? We see as well that some people using some kind of weird credit card that's called prepaid credit card. That's actually, there is no payment on it, right? So there's a small amount on it, and then you cannot utilize it. So they can come in, spin up big number of machines, using it for whatever they want, and then later they don't pay. So we need to find a way to stop that. Another challenge that we are facing, that people is try to make a fraud to steal a username and passwords, or API calls and keys. So all of this we take care of, and we'll be able to secure it successfully in the last 13 years from where we started as an AWS. The other thing as well, which kind of tricky for a lot of online e-commerce platforms, and anyone is utilizing the web services, is the app use of the free stuff, free tier. People just keep trying and creating multiple different accounts for the same person to keep misusing or abusing the free tier. Or, for example, they put like a phone number that's actually prime phone number. So when we call them back to support them on their ticket that they raise, it's actually being a chargeable call where they are making money of it. So everyone on the same boat. We are successfully being fighting and working against this in the last 13 years. But the challenge, as that Dr. Krishna made, and this is the biggest challenge, and I'm happy that we are aligned on this, that the attacker is always smart. They always find a new way for that. And you need to keep in mind that it's not just like you want to prevent them to stop, because sometimes leakage can happen. Sometimes people can pass your prevention system that you build to stop them. So you need to think about the fraud strategy across 4 main areas. The first one, how I can stop them in front of the door, how I can prevent them from getting inside my system and doing some sort of fraud. The other thing is, what happened if these people get in or starting to abuse my system, or I got a couple of frauds, how quickly, and that's really very important key on the fraud detection, how quickly I can figure out this and I can stop that. The third important action is how I do this remediations. Is it done manually, so it will take a long time, or I have an automated way that can come and stop this? And then how I can translate this as the last step to a rule or a way that I learn from, so I can use it to stop and prevent anyone come to me. So I want you to think about fraud detection in this way. So it's a full cycle. I'm going to be sharing this slide for you with you, so don't worry. You don't need to take screenshots or just like wasting your time writing a couple of notes or copying from a slide. I'm going to be sharing this with you, and I'm going to be moving a little bit fast because I want to cover a couple of demos as well. So the first thing, when the people start to think about fraud detection, they say, the easiest ways for me is to write a bunch of rules. And we have code, been using development for many years. We can write a fantastic solid rule that allow me to stop that. Like this rule that you see here, right? Like, for example, if I get an IP address from Japan and the address is mentioned Japan, but the phone number is coming from Spain, then this rule will trigger investigation. Maybe this is a fraud transaction, or maybe this is a fraud registration. Someone want to keep misusing my free tier. That's kind of a rule-based. But by time, and the attackers or the fraudsters become more smart and smart, you find that this has become so complex for you, because this static rules is always going to be behind. And you will not be able to know it is behind until someone breaks them, which is the damage will be already happened. So we need to reduce this. And by time is getting very, very complicated and over-engineering. And the last thing, that it cannot scale. Think about rule that you are searching for a needle in a haystack. You have this big haystack, you jump in, You keep searching and searching and searching, and if you're lucky, you'll find it, okay? And if you're lucky today, I'm not sure if you will be lucky tomorrow to be able to find this one. And the big challenge that you are thinking that you are good, but the guys are maybe already there and misusing your system, and maybe by end of the month or maybe sometime end of the year. And unfortunately, even there's some organization discover this after a couple of years. So it's really complicated. So you need to find a new way, a dynamic way, something real time, something actually self-learning, and it's actually easy to maintain and scale. And for that, people say, okay, let's use a machine learning. So let me ask you a question, a quick one. I know that we are virtual, but just we get attention for everyone. Why do you think people decided to make a machine learning? Let me go to the comments here. Come on, just give us an idea. So maybe we share an awards later for the best answer. Why people is using machine learning? Why people decide to have a machine learning? Just throw some ideas.
And the awards will be sponsored by Amazon.
I didn't say that. I think it'll be award, maybe from Middlesex University.
So that's a good question. Everyone, if you can just type in using the YouTube comment or Facebook, if you're watching live on Facebook, just put in a comment on.
Yeah, to find pattern. That's very good. Faster and more insightful. Amazing. Machine learning is faster. Okay. What else? Gain from experience. That's amazing. Good one as well. Okay. Any more ideas? Dynamic fraud detection. Nice. Yeah. That's what we're trying to presenting today. Okay. I have a different point of view. We invent machine learning because we are lazy. That's a human nature, right? We want to make things in a more simple way. We don't want to keep writing a lot of code. And that's why we invent the machine learning. So the idea before that I get my data and I need to be the one who write the rules to get the output. With the machine learning, we do the other way around, right? I get my data and I get some data that I know the output, which as Dr. Krishna was saying, that's gonna be the fraud detection or something. And I will leave the computer. I go and take my coffee and I'll leave my computer to do all this crazy math and get me the rule. Then I will take this rule and apply it in fraud detection. That's why, from my point of view, why people invent machine learning. Anyway, just way back quickly to our example. So the machine learning for fraud detection is, as we discussing, is actually address a lot of what you just mentioned now in the comments. And thanks for sharing this in the comments. So because this fraudsters always do a lot of tweaks, so you need to always be dynamic to capture that. And as well as it's more robust and easy to scale to do this. So what's the type of machine learning that we can be using with the fraud detection? It's the same type that you can use it in any machine learning. So you can use supervised learning, you can use unsupervised learning, or you can use the reinforcement learning, which actually you learn from pattern. But that's very tricky and dangerous to do it in fraud detection, right? Because you're going to be with the system for some time, and this system will keep listening for long. By that time, could be a lot of fraud happening. But the amazing thing, and that's I just recently saw it in one of the research paper that they say that you can combine multiple of those, right? So I can use, for example, anomaly detection algorithm, which is unsupervised, to trigger the investigation on trigger and high alerting case that I have. Then I can pass this to a supervised learning, which can run some sort of classification algorithms, let's say XGBoost, for example, that to further evaluate this model. Then I can as well pass it to human to do an manual investigation. And maybe on top of all of this, I will have a basic rule. So maybe to reduce the cost of the machine learning, instead of I do a lot of inference, I will have my rule-based first, then I will do my anomaly detection, then I will apply my supervised learning. That's all can be combined. So the supervised machine learning, you build what we call a model. And a model is you get an algorithm where you need to give to this algorithm a data which is labeled. So you need to label this data So either by fact, that's that's happened, it's fraud, or from your team expertise, that some of the team will say, okay, this is fraud, this is non-fraud, and then you give this to the algorithm. The challenge, as Dr. Krishna mentioned, I'm going to see this as well in the Jupyter notebook that I will show to you within 15 minutes from now, that's a big issue of the unbalanced data, that you have 90% is non-fraud, which is good, maybe 10%, or even in some cases 2% or 1% even is fraud. That's a good thing for business, but not a good thing for the equation and math. So how we solve this, we're going to be seeing it in the Jupyter notebook. So what I'm going to be doing that, I want to figure out the pattern. So my model will be this red shape that you see here on the screen. And then I will get my data. And this is how we do it. Usually we split it to two parts, to training set and testing set. So I will take my training set, I will give it to my model, which will be trained on it, and I get my model out. I will apply my model to my test data that I know it, and then I'd be able to measure the accuracy. If I'm happy with the accuracy, I will go live. If I'm not happy, I will keep training. This is how we apply the machine learning in fraud detection. So usually as data engineers, and that's a key, and it's a big key function in the machine learning process, is in the data engineer, you need to handle a couple of challenges, right? One of them is, we mentioned, the data unbalance, and the other things as well is the data enrichment. So sometimes the data that you get to the machine learning model is not enough for it to be able to predict the right pattern. So, and you're going to be see as well that we have a service on AWS, which I will show you in a demo called Fraud Detector. We do this automatically for you, because the data engineer need to enrich the data. What actually enrichment mean? Enrichment, that means that I can add from the public data available on the internet, or I can buy data from another service provider that can help me to extend the visibility of my data. Like, for example, I can buy a list of bad IDs, or I can query them if they're available online, right? I can buy from a certain entity the scoring card for my customer that they come and open an account in my bank, right? I can get a consultancy that's helped me as well to increase and reach my data. Or I can combine multiple data to build the new features, right? Like, for example, I can measure the distance between two cities, and based on that I say that this data, which I will be added to my model before, to my data, to my algorithm before I get my model, so I will get a better model. So that's a key point that you need to be thinking about it, how to do it. And I will show you a tool called, again, Amazon Fraud Detector, that we launched it recently and still under technical preview, but it is available. You can request access and try it. That's actually do this enrichment for you. Okay, so again, in summary, that's a comparison between how you do fraud detection manually using rules, or how you do it with the machine learning. But the challenge, if you look even to the machine learning, it's by itself as well, it's not easy to do with the fraud detection. It is a costly process. It's need an ML experts, which can not be easy to find, and maybe costly as well. It's taking a lot of time to transform and prepare the data. There's so many tools on the market that's or open source library that you can waste a lot of time until you get the right platform up and running, so you can start to do your environment ready to build it for the machine learning. So as you see, the machine learning process can be a little bit challenging. That you need to get your data in, you need to build your own algorithm, you need to train it, and then you need, after even you deploy it, and so even if you train it and you get a good result, you need to think how you deploy this. Because when you deploy it, so the bank or whatever your internal customers or your company start utilizing it, you need to be sure that you deploy it in a way that it is secure by itself, so no one will come and attack your fraud detection system. The other thing that you need to ensure that it's scalable, so when you get a lot of hits, it can be still performing well, and as well that you need to ensure that you continuously keep training and enhancing your fraud system.
Ahmed, we do have a question from Anisa, and she's asking the fraud detection data, does it have a class variable?
Can you clarify what you mean by class variable?
Anisa, if you could just give some more explanation of what actually do you mean by class variable. If you're asking about the fact that fraud or not, definitely that is there in the data set. But if you mean something else by class variable, please put it in the comments and we'll pick your question later. Thank you, Ahmed. Please go ahead.
Yeah, sure. So our mission in AWS is that we try to put the machine learning in hand of every single developer, right? So we need to make the machine learning available for everyone. And for that, we're providing the right set and tools that allow you to do that. So this will be reflecting about what we are talking about in the machine learning fraud detection today. That's the ML stack of AWS. I will not spend time on it today because this is so much to be covered. But just for you, this is what we will be covering in the next 30 minutes, is this service, which is AWS Fraud Detector, and as well as, this one, Fraud Detector, and as well as this service, which is SageMaker. I'm going to be starting by SageMaker first, then I will go for this service Fraud Detector. So what actually this stack looks like? This layer that you see here in the top, this is an AI service. So if you are not a data scientist, or even if you are a data scientist, but you don't want to waste your time and maybe reinvent the wheel, you can just simply use those services. This is ready-made services. All of them is till here, I would say, is model that already implemented and is already trained by AWS. You just hit the API and you get the results. From here, between personalize and forecast and fraud, and maybe we have in the future more session about like forecast and personalize, those you don't actually need an ML or a data scientist experience to utilize them, but actually it is trained on your data. So here you get the algo, you get the algorithms, and you apply your data on it to get the results. Those is already trained, okay? So we're gonna be focused today on this one. And the next one is the SageMaker. So SageMaker is a platform that's cover all the layers that we was discussing in the previous slides, and allow you to build and train and deploy your model in production. So it's a framework allow you to easily do that. If you wanna jump inside a machine and get everything ready and installed for you, powerful machine with GPU and CPU, you can use this layer, which is actually built for machine learning practitioner, that's allow you to utilize TensorFlow, MXNet, and PyTorch, and even abstract layer on top of them like Glue and Cross or Scikit-learn. You can still even use this one aside SageMaker, which actually we recommend. And this is the full stack for you. But if you still want to have like a single machine, do everything inside the single machine, you can still do that. So this is what SageMaker is giving for us. So SageMaker is covering all this layer. Cover the first layer of a tool that allow you to bring in the data, to label this data first. You remember we say the first thing I need to label my data. So there is a feature inside SageMaker called ground truth. So you get your data in and you allow people to label it. And then the next layer inside SageMaker is allow you to build. What I mean by building is I need to have an environment to write in my machine learning models, the machine learning algorithm, and cleansing and cleaning the data, get everything ready. And usually the data scientist is using Jupyter notebooks. And that's what we have here. With one click, you get Jupyter notebook up and running and you can consume it. And then once this is ready, you can just deploy it in getting inside AWS, and you say train or fit, depends on the algorithm that you use. So it will provision in the back end and cluster of one server or more to do the training on it. So think about it. Here, you are writing or you are building in a very small machine, okay? but the training itself, it's happening in the back end in a bigger cluster that you'll specify. And I will show you this is on my Jupyter notebooks. And the last step, once you finish this, you just write .deploy, and that will deploy in the cluster. We take care of auto scaling, we take care of monitoring, we take care as well, help you to build a pipeline for that. So that's the definitions of SageMaker, and it used to be like in a multiple components. Now we are unifying them under something called SageMaker Studio. It's getting a bit easy, get you everything within same place. So SageMaker Studio is actually based on Jupyter notebooks. So if anyone who's used Jupyter notebook, he will find SageMaker Studio is something quite familiar for you. Where you be able to, with one click, as we mentioned, set up or get a notebook instance that allow you to do all what you need. And with one click, you deploy, one click, you go in production. And as well, it allow you to do what we call experiment, right? And that's a key thing. And I'm sure you guys know about that. Machine learning is not like one rule that fit everything, right? You need to try a lot of things, right? We have this crazy thing which called hyperparameter that you need to keep trying and fine-tuning this. You have a different data. There is a correlation between the data. There is an imbalance. So you try a lot of things. Then after you do this and you write it in a paper or something, you need to compare these results, which was quite challenging. So with SageMaker Studio, it's going to be C as well. You can bring all of this together in one place, and you can compare all of those together. So SageMaker try to make things more easier for you. So as you know, every algorithm, usually when you train on it, usually people either they install the prerequisites of this algorithm, or you get a container, say Docker containers or whatever, and you deploy your model inside it so it can go in production. So SageMaker come with a built-in 17 algorithm for you. And some of them we're going to be using in the fraud detection. So for example, under classification, you'll find a linear learner. So if you just want to do like, binary classifications, you can use this one. But there's the Swiss knife algorithm, XGBoost, which we'll discuss a little bit in details in the next slides. That's as well part of classification. And so many other algorithms, and some of them is actually deep learning algorithm like computer visions, like sequence to sequence, that allow you to do all this step with one click, as you're going to be seeing on the demo. Before going into the demo, we'll maybe switch a little bit to the theoretical part. That's one of the best book that I read in this area, and actually I appreciate your feedbacks on the comment. If you have another good book as well, I'm interested to read about it. So if you know an interesting book, please share it with me. I'm happy to, I'm looking to dive deep and read more books as well. But that's one of the books that I read and I like it. You can go and read it as well. It's cover the good common algorithms that's in the market that's mainly focused about fraud detection. Some of them is actually more detective, and some of them is actually come for supervised learning as well. So you can have things like k-mean clustering. You can have things like support vector, linear regression, logistic regressions, decision tree, and XGBoost, which enhanced version or like a combined version on top of decision trees. And you have as well deep learning algorithm that people start to use as well now in anomaly detection in the fraud detection, which is like autoencoder inside neural network. Okay, so that's a nice book. I read it and I like it. If you have another books as well, let me know. I'm interested to read more on this topic.
Sure. Ahmed, just a point of view here. So do you think from a theoretical perspective, the fraud detection demands a different kind of a field altogether? Or is it that someone who is theoretically strong in typical data science and machine learning methods would be able to master fraud detection? So is that because you did show a book exclusively for fraud analytics? So I was just wondering, do you consider from a theory perspective, it demands a different world?
No, it is the same. Like most of the stuff here, if you are aware about the machine learning and the algorithm, you find it similar, the same. The different is mainly coming from how you understand the business problem itself and the aspect of it. And the art, and actually this is the art of getting the right feature in. That's the key things.
Correct, and that's one of my favorite points, Ahmed. In all the machine learning problems, one of the things that I really focus on is the domain knowledge, which many of the data scientists today do not spend much time on, and immediately jump to modeling and start deriving insights without focusing much on domain knowledge. And this is where your point of investing in domain knowledge actually makes more sense. We have few questions. Diman is asking, is there a possibility to customize the existing solution models in AWS?
Yeah, because you train the algorithm on your data. So definitely the answer is yes.
Okay. And Bisher Zumot is asking, what's the recommended software for visualization in the area of fraud analytics?
So it depends what you want to do. So you're going to be seeing the Jupyter Notebook now. I'm using Matplot. So I'm just plotting them with the Jupyter Notebook. It's quite fine. Yes. You can as well use SageMaker Experiment. So a SageMaker Experiment is give you this comparison between them. But I would say most of the people is using MMPlot library inside the Jupyter Notebook itself.
Sure. And one more question from Pallavi, one of my ex-colleagues. Do we have transfer learning included in this as well?
Yeah, if you are using a deep learning, yes, transfer learning is there. AWS Fraud Detector Service, specifically in top of the SageMaker, is actually using this one. And that's a part of the data enrichment that we do, or enrichment for your algorithm. Yep, that's there. So I'm quickly going to be going back slide in sake of time. So XGBoost, that's the one that's going to be using in my Jupyter Notebook in the next, on the first demo that I will show. So XGBoost is actually, they call it the Swiss knife. If you look for Kaggle, for the people they know Kaggle, it's a very famous online machine learning competition website. You can go and try to compete. XGBoost is actually did a great result in a multiple of competition, as you see here, compared by any another algorithm in the market. So the idea of XGBoost is that it's using a supervised learning. And before we going in and maybe dive a little bit about XGBoost, just a quick recap about the idea of the regression in general, right? So if I have my data that I can actually split them between two areas that you see here, like I have fraud and non-fraud, and I have this, clear line between it, then the life will be awesome and amazing. And that's going to be a very simple equation that you can see here. That's y equal mx plus b, which is usually, a b here is equal to the value of y when x is equal 0. And then I have my coefficient that I'm trying to find, which is the slope of my curve that I'm trying to find during the training. Unfortunately, that's not that easy. So there is a lot of techniques that's come on the market. One of them is XGBoost. So XGBoost is kind of having this three definition of based on a certain conditions. So let me show you that. Yeah. So think about this one. So XGBoost is come as an enhancement of the three algorithms, right? So the idea is very simple. The algorithm is trying to find a certain of classification that based on that, I can giving a score, so I can be separating my model based on that. So for example, as you can see here, if I'm trying to predict if this person is actually using computer game or not, right? So I can say I put a certain condition, or the algorithm will try to figure out this condition. Like for example, if the person less than 15 years, then if yes, then I will give him a certain score. Then if he's male, then I'll give him 2 points, and this is why he's getting these 2 points. If you look for the other condition, like for example here, because he's actually maybe more than 15 and whatever age is here, I will give him -1. But maybe because of this girl, it's getting one layer yes, another layer is no, then I will give it different score. Then I will combine this classification that I am doing with regressions, and I will give this a score. And then I will have this as a one tree. And then what I will do after, and that's the idea of XGBoost, that I will ensemble those models to do boosting, where I will get a multiple trees together, and each tree will be getting the output of the previous tree and try to enhance and solve and reducing the error from the previous tree, and so on, right? So I will get my the scoring from the first tree. Then I will build another tree, try to enhance this one, and it's actually going to be working well. One of the challenges that maybe in XGBoost and a similar algorithm as well, the idea of overfitting. And this is why we need to do what we call regularizations. So the tree itself, it's allow you to reduce the training loss. And I mean by training loss here is the errors between what you predict and the real values. And that's a very simple equation, right? So I can have what I get, I will compare this with what was actually the real values, and getting the output of this, and that might be training loss. But the challenge, as I told you, that your model, if it's so much deep on this tree, it can be overfitting. And for that, there is a technique called regularizations. And there is usually two types of most common regularizations available. So there is L1 and there is L2. So L1 is called lasso L1. So with this one, you are actually getting a parameter, which is here you can see is lambda, that's allow you to fine tune the L1, where you can reduce the accuracy of your model. That maybe it's a little bit crazy, right? So I don't want my model to be 100% get the right results. And maybe this as well is getting back to the point that that I can get as a data scientist, a model, let's say, okay, that's getting me 95% or 99% of result. When you take it and you do it in production, it's actually overfitting, so it will not help. So for that, you need to apply some regularizations. Most of the people in the market, I see them, they use L2. So they use reg because it's less computational costly compared by L1. But both of them is the same idea. And just to visualize it for you, if I have some data here and I want to build a model for that, if I build a model with this shape here, that's, as you see clearly, it's an overfitting one, right? Because it's captured a lot of noise. And I mean by noise here, it's a data point that's not important for the model. And the next one is another one that's underfitting algorithms or underfitting model that actually not captured a lot of the trends. So here I can see that getting in between is the best thing, right? There is no time to cover this area, but this is was an interesting as well to know how actually we know, and based on what we decide my tree B looks like. There is multiple decision algorithm or decision tree algorithms that people usually using, and you don't need actually to do this manually. Scikit-learn it's do this for you. The things like GenieIndex, things like information gain, all that stuff is going to be done with you. And when you go on SageMaker and fraud detector, you don't need to actually go much on that, but it's interesting for you to know about it. So it's a really cool algorithm. It's doing a lot of things. So let's maybe quickly jump to a demo. So I will show you. So this demo that I will show you here, it's built with one of my colleagues, and I put the GitHub for him is here. His name is Will Bedder. So you can go and check his Jupyter notebooks. I'll quickly touch base on that. Then I will come to the interesting another demo of AWS Fraud Detector. So
Ahmed, before you switch to the demo, we do have some pending questions. The first one by Dhiman again. What are the standard business KPIs in the domain of fraud detection considered for value evaluation? That's an interesting question.
Yeah, so area under the curve. So okay, so before going on this terminology, the best thing that you need, or the biggest challenge that you will face, that you need to go and explain it by yourself for the management. So first, right, because when you go for the management and say, okay, I get a perfect algorithm that area under the curve is 0.999, and here, okay, thank you. What this mean actually? So you need to translate it, and that's one of the biggest challenges with deep learning, by the way, right? Because it's tough to explain. But in general, you see, area under the curve, confusion matrix is one of the things that people is using a lot. Yeah, that's that precision and precision. It's one of the key things as well that people is using.
Wonderful answer, and I think that's pretty important, what you convey to the management. There's another question on how the neural network could help as the input is constant, but the weight and the bias could change.
Oh yeah, so that's the idea of neural network, right? So in the neural network, when you build those layers forward, which we call like feed forward, then once we get the result at the end, we compare what we get in the results, and we try to go back within the neural network, adjusting our weight, which we call back propagation, and we keep doing this back and forth until we adjust our neural networks, been enhancing. The main thing that why we use neural network in fraud detection, to detect the anomaly detection, to detect the anomalies inside our data.
Sure. Thank you, Ahmed.
Yeah, so I need to jump to the demo. It's 10 minutes, and I want to show you a lot of stuff. So that's the interface of SageMaker. So it's inside AWS. It's come as well. There is a free trial. You can go and try it, but be careful. Don't fire any GPU machines. It's really costly, and go beyond the free stage. Anyway, so you see here the section about ground truth, notebooks, training, inference, blah, blah, blah. So the first thing here, I will have my training instance. So training instance will be the place for me to create a Jupyter notebook. So I will come here. I already created a notebook instance. So I can open this notebook instance here. And I'm using here Jupyter Notebook Lab, or I can use Jupyter Notebook as well, instance itself to be open faster. Let's save some time. It's loading. So I'm getting here my instance now ready. So once it's loaded, I have inside it, I think I opened it here, okay. So I have inside it my Jupyter Notebook. So this is my first Jupyter Notebook. The data set that we are using here for the fraud detection, it's actually data set coming from Kaggle. It's about, it's actually 2 days of fraud and non-fraud data coming from a real transaction in Europe in September 2019. As you see here, there's a huge unbalance on the data. There is only 492 fraud out of our data, and there is 284,807 transaction, which is actually non-fraud. And that's totally unbiased of the data and can make a lot of challenges for me. And this is how the data is being looked like. For the people that didn't use Jupyter Notebook before, it's a kind of GUI, I would say, a place that you can write your comments and you write your code in. This Jupyter Notebook, I will share it with you. Here, my colleague is explaining what the machine learning process in general looks like. I give a couple of ideas what XGBoost as well is, and there is a link of the XGBoost here. And then starting from here, we start utilizing SageMaker. So within SageMaker, I import a couple of libraries, and a couple of the main libraries that everyone is using as well, like NumPy and Pandas, and it's very important. Then I just install XGBoost. Then I download my data. So this is my data set, as you see it here. As you see my data, it's 28 feature inside it, which we don't know actually this feature is related to what. It's all like masked data. And then I have the amount. Then I say it is actually fraud or non-fraud. So I get my data, and then I just describe my data. If I get my data frame, I click describe and I write describe. I will notice two challenges that I have in my data. First, the challenge of my data is the unbalance that we mentioned. The other challenge as well, that the data itself, the values, there is a big gap between them. So the value of time between the minimum and maximum compared by any another feature that I have here, that's a big difference. And that's actually come for time and as well come for amount. And for an algorithm like XGBoosting, which you're using things like gradient descent and that stuff, that can actually really impact the accuracy of my algorithms. So I need to adjust this. So if we plot this here, as you see this is all my data and this is only the fraud, right? The other thing that I need to check inside my data before start the training, if there is any null values. The good thing here that we don't have any null values on my data. Then I need to draw these correlations. And because my data is unbalanced and my data as well, as I told you, the scale is different, I don't see much of correlation between my data here. So this section and the Jupyter is walk you through how we can address these two problems. So the first one is we are using something called robust scalars. So robust scalar library has helped me to allow to adjust the scale of my data. So if you look, we were suffering from the amount. If you see now the amount, it's been reduced big time. As you see here, the values compared by the values that I had before. So for example, here, my time scale is between this value, which is -1 and 1. While if I look here, before I balance my data, it was between these two things here, zeros and I don't know, this big number, right? So here we'll be able to address the first challenge. The second challenge is to address the unbalance in my data. So there is two techniques and two different libraries that I can use here. One of them to do undersampling, which I mean I will reduce the data that's it's non-fraud to be equivalent to the fraud, or I can oversampling, and there is techniques from that I increase the data set of my unbalanced data to be equivalent. And I have the two techniques here. So the first one that we use to undersampling, which we undersample to almost 1,000, so 500 fraud and 500 non-fraud. And the other need we assemble as you see them here. Once I'm ready, I plot again the relations, and I can see here that there is more relations between them. The last challenge that I encourage you that you need to take care of before you applying your model is that you need to take care of outliers. And that's a tricky one, right? And one of the best plotting diagram that you can use to detect that is box plot. So box plot is a way that allows you to easily spot on the median and the upper quartile and lower quartile. And as well, you have these two edges, and anything outside these two edges here, you will be considered as an outliner. So I see here, I have outliner here, and I have outliner here, and I have outliner here. Then what I'm going to be doing here, that I will remove those outliners. Just simply here, I write very query, I feature, like, feature 14, feature 14, and I say remove them. And now you can see that I remove them. Once I remove them, I will split my data 70% for training and 30% that I will use them for validation. Once I'm done, I will be ready for training. So training on SageMaker is very simple. All what you need to do in SageMaker is first, you import a couple of libraries and you define what we call estimator. So estimator is like a bulk or a group of what you're gonna wanna decide to use in your training. So in this, I will decide that this is my data set, which is the most important thing. Where is my data? Then what's the output where I will save my artifacts later with my output of my data? And what is the machine that I will use? So this is a machine which is called M5 XLarge. It's not on top of my mind what's the specs of this machine now, but it could be like, I don't know, 4 CPU and 16 gig RAM, something like that, right? Then I can tell SageMaker either I train on one machine or more machines. What's happened now that SageMaker on the back end will go and fire this cluster for me, get the XGBoost container ready, copy my data inside it or stream it, and train my model, and then I get the results. So I will train my model, and then I will be able to get my results. And one of the easiest way, as you can actually see this here, so you can see the error, validation error. So you see the validation error. It's actually pretty good model. It's, I think, almost like 95% or something like that from accuracy perspective. And the easiest way is you print out the confusion matrix, and that makes sense a lot for the management. Very easy to see. So you can tell them, I have here the false positive and the false negative. So I can say that out of 100 items that I use for data set, the actual for that was 45 and 47 was actually detected correct, which is true positive and true negative. True positive, it means it was a fraud and I detected, and the other was true negative, that was not fraud and I detected not fraud. And then I have false positive and false negative. So false positive, it's mean that it was actually not fraud that I detected as a fraud. False negative, that unfortunately it was fraud and I didn't detect it. And that is an easy way to do this. So this is how SageMaker allow you to do that. That you can do it very simple through a UI, through the Jupyter Notebook here, or you can even do this through a UI of SageMaker. So I can come here, I can create a training job. Sorry, I'm going quickly. So I come here and I say, I want to create a training job. And within this training job, I can use whatever the algorithm that I want to use to do that. So I use XGBoost. So again, you can use it UI, you can use it as well from the Jupyter Notebook. I will leave this aside. That's done with the SageMaker. In the next 3 minutes, unfortunately, you don't have much time. I want to show you a very interesting service which called AWS Fraud Detector. So maybe you said, okay, so you say that AWS is want to put the machine learning in hand of every single developer. I think this is still too complex for the people who's not a data scientist. So how actually we make it much, much simpler? This is the service which is called Amazon Fraud Detector. And the data set that I will be using here is a very simple data set. Let's bring it here on the screen. So it's have 3 columns. This is the data set. That it's have an IP address, it's have an email address, and it's have a certain time, and if the data is fraud or not. And I want to use this to actually predict if the user that it's coming to my website to create a new account is a legitimate user or he's trying to do some fraud. All what I need to do is I go to the service. Very simple. Forget about SageMaker now. And I say, you know what? I want to build a model. Okay, so I want to give this model like Middlesex University, for example, right? And just give it any name. And I say, I want to do an online fraud insight, which allow me to predict if someone try to misuse my infrastructure and misuse my data, right? And then I need to specify what is the IAM role. And then I say, where is my data is saved? And then I click next and I start. So that will take some time to be importing the data. I already import the data. And I have my data here is imported. As simple as you just saw. Once my data has been imported, I can come here and I can say, train my data. So now I'm training my data. So I didn't specify any algorithm. I didn't do any enrichment of my data. I didn't do any feature engineering. All what AWS is doing now is looking at my data, try to understand what's there, and try to apply the best algorithm. It can be XGBoost, it can be autoencoder, it can be, I don't know, if maybe linear, something simple as that. And once it's been trained, I will have my model ready and trained for me. And I can see this is a very interesting interface for you. I can see the accuracy of my model. I can see as well how the model can be easily explained to the management. So for example, you see here that by writing the rule here, that if you say that I want to decide that my rule, that I say it's a fraud or not fraud, it's 500, I will be able to capture 65% of all fraud, okay, while I'm accepting the risk of only almost 1% that is inaccurately labeled as fraud, which is false positive, okay? And I can change that, as you see here, I can change these values. And while I'm changing these values here, it will change as well the readings here. So I can easily explain it to the management. And it's even changing the confusion matrix for me. So if you see here for the 500, it say that for true positive, out of 100,000, I will be able to capture 6,000, and I will be able to capture as a true negative and true positive this number, and the false negative and the false positive will be this, which is okay, not bad model so far. And as well, if I want to see the area under the curve, it's give it for you here. The optimum things for area under the curve, as you all know, is a 1%. Sorry, so as a value of 1, which is, it cannot be the case for any model for sure. But this is, you can easily see here what's the best value for me if, and every time it tell you what's if the FPR for it. Okay. If you want to see the precision, you can click here on table. So it's gonna show you the precision, and you can say that actually that's one of the best values here, because I can get only 4% as a false positive rate, 83% of the true positive rate, and precision is 68%. You have all these results. Once you are ready, you can come to the model and you can come here and say, I want to deploy this model. Once the model is deployed, it deploys something called predictor. And that's deployed as an API, where you can easily come to your predictor here and hit this API from your application and start to get the results. And in the console as well, let's give you a nice thing, you can do that. So let's take one which is not fraud as a quickly. I know that we are running over time, but just quickly, we'll take this as an IP, and we'll take this as an email. Again, this is through your mobile application or your web interface or your banking or whatever. This is all will be done on the back end as an API. So I can run test, and I can see that this is, it's called approved, because I customized it to call approved, and is actually considered that this is a good transaction. If I get another one, which is fraud, and I hope my model should be fine and predicted in the right way, change the IP, I change the email address. So this service is currently in technical preview. You can request access to it. So it's much, much easier compare with just using any other tools. Definitely, maybe it's not a fully flexible and visibility for you what's happening in the back end, but it depends on your case. So you can see here, the outcome of this is say review. So we consider this as a fraud. The way that we define these variables, I defined them yesterday by giving, a simple condition. So just to make things as, easier for you to read. So for example, I say approved, which means when the model is correct, right? So just wanna go back as well to the slide. So that's what actually was trying to tell you about that Amazon fraud detector. So this is the service that I just showed to you. Definitely, there is no time to go through the slides. But again, quickly, the whole idea, I get my data in S3. I train my model automatically. AWS do data enrichment, doing transfer learning for people who are asking about transfer learning, getting our knowledge and our experience about the bad IBs, bad email, blacklisted stuff, and then we can enrich your data. We train it and we deploy it and we maintain it for you. And then once you're ready, you hit it with the API and you get the response. Yeah, and I put here on the slides a lot of definition about this. So I'm going to be sharing with you just to get the slide more reach, so you can go and read that. And with that, I want to thank you for staying for me 5 minutes more over the hour. And I'm happy to take any question here or maybe later over the email as well if you wish. And wish you a great week ahead, guys.
Wonderful. Thank you so much, Ahmed. I think we are in no rush for time. I'm sure you have other commitments, but given the interesting session, we just wanted to keep this going. But thank you so much. A wonderful demonstration and a very insightful session. We do have few questions. I'm sure we cannot take all of them given the time, but maybe I'll select one or two questions. So we do have a question from Sahid, and he says that you have used Robot Scaler for scaling your values in data. Is it different from the normalization and standardization feature scaling techniques?
No, not really. Let me share with you the details of the library. It's an easier way for this to do it, right? You don't need to thinking how you do it yourself, and how you do the normalizations and the standardization. So it's kind of try to find the best method for you and give it to you. So it's easy library that you can be using from Scikit to do that. You can find the documentation about it, and I can share it as well.
Sure. Abdul Manan is asking, again, coming back to where we started, the data is heavily imbalanced in terms of the categories. So how successful are the over or the undersampling techniques, and what techniques are generally used in the field to overcome this imbalance?
So see, again, every problem have its own way to handle, and every business is going to be accepting a certain range. If you able to give them sometime even a 10% improvement, that can be a big thing for them. It doesn't require that I reach 100% or 99%. It's different. I saw even a couple of cases that the model enhanced for them 10% compared from what they was doing. And by the way, it was even below 80%. They was extremely happy because this 10% is reflect to a couple of millions of dollars. But there's a big thing between difference of the way that you answer this question in the academic and you answer on the field, definitely with all respect with the academic. But maybe I will spend so much time and effort to enhance my model for 1%. I can spend maybe 6 months or whatever to enhance it by 5% or 2%. But that's actually for a business doesn't mean anything, right? Or I can actually say, okay, give me 10% better results, okay, which move me from 60 to 70. That saved me a lot of time on money instead of you want me to wait for 2 years to get me the results. So there is no direct answer for it. It's a hard problem to solve. I have to commit that. And that's why enriching data and find a multiple way is a best thing. What I would say, combine multiple models to try, or multiple techniques to try to protect from fraud as much as you can. You get rules, you get a machine learning, supervised and unsupervised, and then you get manual reviews if things is not triggered. And there will be always frauds. That don't take me wrong.
Sure. And I think we can take one more given the time. So in general, Ahmed, how would you, so this is a question from Ayman, how would you comment on the accuracy rate of fraud detector service by AWS, and how is it generally determined, the accuracy rate?
So I'm happy to hear your feedback about the service. It's a new service. We just launched it. So I'm looking for your feedback about it. We have very few customers trying it now. It's still under technical preview. So you have to submit to get access to it, AWS. But the feedback that we get is really interesting so far.
Perfect. And last, I'm sure this is the last. So Abu Bakr says, is there a provision where the fraud detection could just raise an alarm, or could it be used to stop the transaction live happening in general?
Okay, so you say the response that we get, like approved or not approved, that's something I define on the console. So actually, we send this approve to you, this response to your application based on with the accuracy as well, and based on that, your application is taking the logic. So it's not a service that it will stop the fraud by itself. It's a service that you go and consult to get the response.
Okay, perfect. So I think that was a wonderful session indeed. Thank you so much, Ahmed, for your time and your insightful session. Really shows the kind of passion that you have for data science, machine learning. We hope to have more from you. We had close to, I think, maximum participation on YouTube was around 60 at one point of time. And the remaining around 25 on Facebook, so close to 80 of us joining live. But I'm sure many others would eventually view, those who have registered. Ahmed has agreed to share the PowerPoint presentation. So if you have done the registration on Eventbrite, we'll send out an email with the PowerPoint that you could use in future. So thank you, Ahmed. Exactly what I wanted in terms of this wonderful area of fraud detection. As you said, the strategy is different. Fraudsters are coming with different kind of a strategy. So obviously the counter strategies have to be different. It's a whole new game to prepare data for machine learning, looking at objective functions, feature scaling problems, outlier detection. So these were some of the interesting things that I could get from your session, and hopefully we'll get our hands on to the tools on AWS to try and probably give you back some general feedback on the accuracy and on the performance. There were a few other questions which we didn't pick up, but we'll be more than happy to answer those offline. I can do that. So some of them is there on the comments, so we'll definitely answer all the questions. Thank you so much, everyone, for joining in, and thank you, Ahmed, once again. Over to you for a final note.
No, thanks, everyone. Really appreciating you being here. I will work with Dr. Krishna to have more session. I was thinking about forecast. We have an interesting thing that we can do with the forecast. I see people who's asking about certification as well. So AWS machine learning certification specialty is your one. So please go and get the certification. It's not complex. If you're coming from a field, you need to know about a little bit about AWS, and it's really very well respected on the market. So again, thank you. Wish you a great day ahead, and thanks for being with us. See you guys.
Thank you. Thank you so much, Ahmed. Have a good day. Thank you for your session.
See you. Bye.
Bye-bye. Bye-bye. Those who are asking questions about the files and data, definitely we'll share the presentation. The data was from GitHub. We'll share the links and everything. So thank you so much once again, and hope all of you have a wonderful day ahead. And you will join us live for the remaining sessions that we have. We have a wonderful hackathon going on right now, where 170 teams have participated. And we would expect you to join us on future hackathons, and hope for building a good community thereon. Thank you so much. Have a good day.